This is Cremo, hopefully a friend of mine, and we're going to start in a while, but we have some sponsors. As always, you know, it's important. So let me start with the first sponsor, which was kind enough to give us some crypto, actually. Our sponsor is this, this company. I didn't know them before the live. It's a Bahamas-based cryptocurrency exchange, apparently. The exchange was founded in 2019 and has over 1 million users, and is the third largest cryptocurrency exchange by volume. So, pretty interesting sponsor. FTX is incorporated in Antigua and Barbuda and headquartered in the Bahamas, and is closely associated with FTX.US, a separate exchange available to US residents. You might know them from the advertisement with many famous people. So that's our first sponsor. We have another one, so we are getting rich now. Let me open.
I'm not getting anything. Are you getting paid for this?
Do you use FTX, Filippo?
I had no memes aside. I had an account, never had a single cent on it. Like I created it a while ago, never had anything on it. I actually don't hold any crypto.
Oh, this is a good disclaimer. I hold crypto, but like pocket money. So we don't have any specific interest. We are just here for pretty much the point of the live will be to ask, well, Crem about his past and how he got into hacking and everything, but mostly about how to get into smart contract stuff, because he changed, like he wasn't doing this a couple years ago. So when did you start, by the way, doing like getting into bug bounties?
Well, bug bounties basically never. I never really did bug bounties. Not even in crypto. I mean cryptocurrencies audits.
But like before doing it professionally, sorry.
Okay, yeah. Before doing it professionally, I was interested. I knew something. I mean, because the technology was interesting to me. Like I wasn't hard into cryptocurrencies. I mean, I've read something before, played with it a bit, but I went hardcore into cryptocurrencies basically around a year ago.
Okay, before we get too much into that. Okay, so this is just to say that we are interested on the technical point. We don't care about that. We don't have a dog in the fight, apparently. So we don't care about crypto itself.
I feel like I should say we're not really sponsored by FTX, and this is a meme. Just
yeah. And we have another sponsor. So let me. Yeah, so we are sponsored by Mastodon. Not really by Mastodon, but by the people who tweet all day about Mastodon. That's our sponsor. Mastodon is a new decentralized Twitter-like service that is so good that people feel the need to go on Twitter to tell other people how good it is. So remember, like, it always happened to me, like when you got into Instagram and went back, and when you started using TikTok and you went back to Instagram to tell everyone how good TikTok was, or when you wrote on MySpace how good Facebook was, or when you wrote on a piece of paper how good email works. I did it. And now we leave it all again with Mastodon, which is so good that people need to convince others to join. It's federated, which we all care about. And do you use Mastodon, fcremo?
I mean, same as FTX. I have an account, I never use it. So I guess that wherever I register an account and I don't use ends up failing.
I read on Twitter that it's very good, so you should join and use it for real.
Yeah, I've heard that too.
So anyway, I'm gonna finish the script. So you just need to go to knock.social or infosec.exchange or tooth.site or byplus.date or gamelink007.net or Patriot Online or n.osm.town or nagoyadon.jp, freespeechextremist.com, lobstertube.com, social.tron.fr, and I'm pretty sure that if you type whatever random stuff on your keyboard and press enter, you're gonna reach a Mastodon instance. And enter promo code Mastodon is good, all caps, to get 100% off your readership. Again, Mastodon is very good, 100% off your readership. Featuring downtime, XSS, confusing features, a Twitter bridge to post on bot's website because nobody reads Mastodon, and drama over censorship, which is something you don't get on Twitter. So what are you waiting for? Join it, and they're sponsoring the thing. Okay, so back to the real stuff. Yeah, so we were saying, could you give us like a small self introduction? Basically, who you are, what you do, and how you got started in computers and security, maybe.
Well, kind of already said, I'm fcremo. However you want to call me, Cremo, fcremo, whatever works for you is okay. By the way, I mean, I'm here, I guess, because I am into cryptocurrency security. So I will just talk a bit about how I got into it. Before that, I played a ton of CTFs. I guess that's one very useful piece. I mean, this has been very useful experience. But yeah, I mean, I got into Web3 security. I don't even know what to call it. Cryptocurrency security, I guess it's a good definition for it. I got into it because I was getting bored, literally.
By the way, someone is saying that there is a strange echo coming from your... Let's start again. When did you start doing CTFs or security? The first thing you hacked in your life?
Okay, first thing I hacked in my life was during high school. Like I started with security when I was around, I believe, 15, 16 years old. Because
can you speak about that?
Yeah, I can say some things. Yeah, basically, my school was an ETIS. I don't know how you say, like, what it is called in English, but a technical school, basically. And we were basically beta testers for one of the companies developing how do you call it, like the electronic attendance registry service.
Oh, okay.
And yeah, we were basically beta testing their products, so at least we had early access. So I started getting interested into security because they started experimenting with the badging totems. So the ones where you badge the in and out at the start and the end of the day to register that you were at school. I was curious how they worked because I was a total noob, so I couldn't understand how the whole process of passing a contactless card in front of a totem and then that somehow ending up on a server. I was clueless about how it would work, so I rolled up my sleeves and started studying. Basically, that's how I started with hacking networks. Because I first did man in the middle attacks. So I first learned how man in the middle attacks worked, and how SSL strip and man in the middle in TLS certificates, like with a TLS certificate, could be accomplished. And from there, then I switched to the web application side, and I started getting into web application hacking. And I ended up actually
before. Like during university or before?
No, but during high school. Like when I was 16. Basically, like I was lucky that I found plenty of vulnerabilities into that system all over the place. I was lucky that I told my teachers at the time, and they, instead of getting mad at me, they actually helped reporting vulnerabilities to the company developing the registry. And so I started reporting vulnerabilities to them, and after a while we actually started cooperating. So I basically was working with them to help them getting secure, which was, I mean, I was happy about it at the time. I'm still happy about it. I mean, it was a nice way to get started. It was the funny thing was that there were a ton of guys ending up on newspapers because they were hacking the registry, and all they were doing most of the times, at least, they were basically installing keyloggers in completely unsecured laptops or desktop PCs that they had in the classrooms, by basically keylogging the password for the teachers, and they ended up getting caught because they were changing grades and stuff like that. Whereas I found something that had a bit more impact than that, and so yeah, no, and I never used it for malicious purposes. Actually, I always
Of
reported
course.
everything. No,
Of course.
it's true. It's true. I was.
Just so you know, this is the podcast where we try to get people to admit they committed a felony.
I didn't. I actually didn't.
No,
I
we
think
trust you.
that.
Let me try. Oh, yeah, this is better.
Oh yeah, this is better.
And yeah, okay, so you were hacking stuff in high school. You decided to go to Polimi because it's a good university, I guess.
Yeah, I wanted to go to a nice university and be able to learn the most I could. That's why I went to Polimi. Also, I mean, I learned afterwards that Venezia, for instance, is actually pretty good, and also Padova. I didn't know at the time, so maybe if I knew, I wouldn't have gone to
You would have
Politecnico di
studied with
Milano. I
me,
don't know.
maybe.
Yeah, we could have ended up studying together.
And
That
how
said,
did you
I'm pretty
get?
happy about.
How did you end up in Tower of Hanoi and
Oh
Mario and
yeah,
all
I
those people?
remember that. I remember like during the open days at university, like when Polimi wants to tell you, oh, we are great, we are a very nice university and all of that. Um, I went to one of the open days, and there was, I think it was Mario. I'm pretty sure it was Mario, like representing Next Lab and representing the security group at Politecnico di Milano. And I was there like a dumb noob, not knowing anything, asking, "Oh, please, can I please come join City Apps? Can I please come play with you? I won't bother you. I swear I will just learn and I won't ask any questions. I will just study whatever you tell me to study." And he was like, "Yeah, no, you if you come, you can come if you want. You just need to do something and not be like just standing there." I don't. I think that Mario doesn't remember this because I mentioned it to him some time ago and he wasn't remembering. But I'm pretty sure.
I
Um,
think he gets a lot of that.
yeah, but I already knew what CTFs were, and like I was already interested in security back then, like when I was joining Politecnico. Another thing that I was already aware of, for instance, was CCC. I binge watched a ton of talks on YouTube given at CCC, and one of the groups at Politecnico did organize visits to CCC, so I tagged along with them very first at the very first opportunity they got, and yeah, then with playing CTL, I played a lot of CTFs then, and that
And
helped
that,
me
and
upskill.
that's how you get good, and you get into mhackeroni, and then we don't qualify for
Yeah.
DEFCON. But that's another issue. So yeah, let's move to maybe what you're doing right now. I don't know. You can totally avoid the employment part, but what's your area of expertise as of 1 year ago? We said.
Yeah, I was I mean, before getting into cryptocurrencies, with specific in security, I was a web security guy, as we said. Then I did a bit of I mean, I got sidetracked and I started working at Revenge, as you know, doing
Yeah, we were
binary analysis
colleagues.
and yeah, doing binary analysis and stuff. But at some point, basically, I had a free week. So I took basically an extra week of vacation that I felt like I needed. I was getting bored, and I also seen like, oh well, the cryptocurrency bug bounties are actually insane, and so I started,
Insane. Sorry,
and
insane as
they
in
still are
as a lot of
insane.
money. You mean?
Yeah, insane is in
Okay.
that reason. I think it was around the time of Saurik bounty. You know, there was a bounty that Saurik got, that the guy
Yeah.
developed, that developed Cydia, among other things. He got a bounty for, if I'm not mistaken, $2,042, I think, which was record breaking at the time.
Slightly
The-
above
and-
your usual pay grade.
yeah. I mean, you get one of that and you stop working for life, basically. But okay,
Okay, yeah, let's say yes.
almost.
Yeah, it
You're
doesn't
at least
matter.
halfway there. Okay, but
Yeah, okay, agree. You
anyway,
can buy a nice house, let's say. A
yeah,
very nice
or
house.
two. But yeah, that said, I started looking at various cryptocurrency, actually at various blockchain implementation. I started looking at blockchains because I wanted to go like down deep. So I started looking at various blockchain projects, and I actually found a bug in blockchain project that I won't mention. Um, in the end, the bug was in an unreachable piece of code, but the reporting process for them was non-existent. Like they didn't have any process. So I figured this out after a while with the help of a colleague investigating this. But aside from this, I got more interested after that week, and then after a while. I don't remember how exactly. I've seen something. I got interested in Solana, which
Okay.
is one blockchain platform basically. Um, and
Which is
I
implemented in Rust, that's all I know.
yeah, exactly. And I started working on a symbolic executor thingy
Just this is on
for
your own time.
yeah.
Okay.
I was curious. I was curious, and I thought that would have been, it could possibly have found some bugs basically. So I started implementing this. I worked on it for like a week or two in my spare time, and like around the same time, I saw a blog post from my current employer, which is Zelic, um, or Verabit. Actually, they renamed recently. But yeah, that's it. I saw a blog post from them basically explaining what the cryptocurrency auditor life is like. It ended with, "Oh, by the way, we are hiring. Reach out if you're interested." I reached out of curiosity. Basically, I wanted to chat with them. They ended up liking me. I ended up liking them, and so that's how I got here, pretty
Nice.
much.
So you mentioned one thing, and yeah, like it seems. Well, you mentioned a bunch of things that I find interesting about crypto. The first one is there is really no seniority yet in. Like
I
there is
mean,
a
there's
bit.
no 15 years.
Yeah, exactly.
Like there's no guys with 15 years of experience. There are guys who are like, I think that, nah, 10 years is as basically non-existent. I think, especially with the focus on security. There are guys who have more than 5 years of experience in security, I think. But yeah, I mean, very very seniors are very very rare.
And one thing like that I hate about the toxic infosec community. So you were at No Hat with me. Did you catch the talk by Giovanni Vigna?
Unfortunately, I couldn't make it.
Okay, wait. Okay, let's skip over that. Anyway, yeah. So I saw a talk, his talk, which was I think the keynote at No Hat, a conference in Bergamo for international people. Pretty nice. You should come. And he was saying basically that security people are skeptical of everything like crypto related, where crypto means smart contract and stuff like that. And I saw a similar talk at Black Hat this year in Vegas, and they made some solid points. One of which is that even if we as security people don't care about it, the stuff still happens and people get hacked. So we should start to care as a community. I mean, and the second part is that it's fun and it looks fun from the outside at least. And another thing is that things like symbolic execution that you touched upon, since the programs are small enough, you can actually do some pretty cool stuff. So how long did you actually manage to finish your symbolic thing, or in a week or something that you?
I mean, no, that project is, I mean, still ongoing, if you can call it that. No, I didn't have time to work on it anymore, basically. But the current status is it can execute some very basic smart contracts, Solana smart contracts, but it's far from complete.
So
that said,
let's
I
say,
mean, I agree with
sorry.
you. I was saying, yeah, I agree with you that about the fun part and the part where you were saying that programs are small enough that you can actually do interesting reasoning, like with symbolic execution and stuff on them. I think that's true. Like you're not tackling the problem of symbolically executing a whole kernel or a whole driver that is huge. Usually smart contracts are way smaller than, I mean, programs in other in other fields, and they're meant to be smaller because they're meant to be simpler and they're meant to be verifiable. So it's a feature that is small, meaning they're likely to stay small. It's not like a temporary thing, probably. I hope so.
Yeah, I mean, it also, like, the bigger it gets, the more expensive it gets to run it, I guess. Or anyway, more bugs you're gonna find in it.
Well, that's for sure. I mean, the how big a program is very correlated to the amount of bugs it has usually.
But so let's step back a bit. Let's say I'm new to, I do city. Well, the people that are gonna watch this are already into security, doing security jobs or doing CTS and stuff. So let's say I want to get into crypto security. How would you recommend to start? And what are, like, so I know of Solidity, which is the language that it's used for Ethereum and a bunch of other smart contract platforms.
Blockchains, yeah.
Yeah, blockchains. And it, like, the syntax is JavaScript-like or Java-like, I don't know. And it seems like it's not too difficult to pick it up. So first thing, what languages do you need, and do you need to be good at them?
Yeah, okay. So Solidity, I mean, it reminds you of JavaScript because it's a bad language. It's not really. It's not. I don't know. It's like
The syntax, I mean, only the syntax.
The syntax, yeah, kind of. It's the very. I mean, the aesthetics are similar because like it has Angular. I mean, the brackets. It's aesthetically is similar to C or to JavaScript or to like languages like that, but for instance, the defining characteristics of JavaScript, so the event loop or the fact that there's a inheritance by, I mean, no inheritance, but that there's a prototype based inheritance is probably the incorrect word, but I don't have the right one. Anyway, nothing like that. It is a bad language. Is in you can see that it wasn't really designed from the ground up with the spec in mind and then implemented. It's sort of like things bolted up on top of each other, both from a security perspective and also from a feature perspective. Like they added some stuff over time.
Yeah, I remember that one of the big vulnerability classes at some point, well, I don't know if big, but one of the main ones were like integers overflows or stuff like that.
Yeah.
And I think exactly. Now they fixed it. Like they check it, the compiler checks it. Like,
yeah,
I mean,
basically basically up until a certain compiler version, 0.8 to be specific, they weren't checking for overflows and underflows, so you had to check manually. And if you forgot, oops, you could send more money than you had because it just underflowed often. So there was a period of time where these bugs were kind of common.
Which sounds like a CTF level of bug, to be honest.
Yeah, not even. I mean, were really easy bugs. I mean, nowadays those are basically non-existent because the compiler automatically checks for overflows and underflows, and it reverses the transaction. And like, if you really want something to be able to overflow or underflow, it needs to be in an unchecked code block.
Okay, so you can
And
still
you
have unchecked stuff.
technically, yeah, if you really wanted to, but I mean, you can even write some sort of assembly if you want to. Often it's done to optimize stuff. Like if you have some piece of code, some function that is called very often, and you want to minimize the cost of calling that, you can write it in assembly. Um, you need to know what you're doing, of course.
Assembly meaning.
Their own version of assembly. Yeah, there's an assembly dialect called YUL, YUL,
Okay, I
um,
think I saw it. Yeah.
that almost directly translates to EVM opcodes,
Which is Ethereum. Okay.
which is the VM used by Ethereum. But we were getting a bit.
Yeah,
I
yeah,
mean,
yeah.
we're going
So
down the rabbit hole.
yeah, yeah.
You asked if what languages or
No, no.
like
I
how to
mean, in
get into
general,
it.
yeah, exactly. Because let me start by saying how I don't know much about. Well, I only looked at Ethereum and just for like a weekend, but it was enough to understand the basics from a. At least like I don't understand completely how the blockchain works, but that's not needed, I guess. But the way I did it was, yeah, I was reading about some hacks, and at some point I started to to with this idea of starting a fuzzer for Ethereum, and so I forked the Ethereum VM source, started reading how the bytecode is interpreted, and then you get into the point that you need to actually deploy a contract to see what's going. I like to get my hands dirty, let's say. And so I got into like remixproject.org, which is like the online IDE, MetaMask, and how to deploy on the testnet. And that was just stuff that I needed to get done in order to be able to start to experiment. So I wonder if your experience was similar, or if you just, I don't know, how you approached it.
I mean, I started with Solana, which is it's actually harder to work with than Ethereum because there's just less documentation and it's more complex, I would say, than Ethereum. And the tooling is like there's less tooling and it's worse, generally speaking.
Okay.
Um,
Is it
which
sorry? Is
said
it
which
very different from Ethereum from like a programming point of view?
it is different. Yeah, there's a it has a it has some significant differences. Yeah, if you want, we can go into
No,
them
no,
a
no.
bit
Let's.
more.
It's just. No, no, I just wanted to know. Highlight. Go on. Sorry.
It is, yeah, there's some. I mean, it is different from Ethereum, but with regards to how to get started, I think that the best way, especially if you already come from a CTF background, is just doing CTF like challenges, but about cryptocurrencies instead of like about web or cryptography or binary pawning or reverse engineering. Those skills actually translate pretty well into like doing code review for blockchains because like if you are used already to taking a program, seeing how it works, understanding how it works, reading through all of it and finding bugs, the process is the same. The vulnerabilities are different most of the
But
times
so
at least,
do you have
but
do you have anything to recommend? Like any?
you mean specific resources? There's
Yeah, yeah,
ton.
yeah.
Yeah, there's tons. I mean, I don't have a name like a specific name for challenges right now. I mean, there's tons of
Yeah,
them. There's
okay. Because I also did to start with some. It was more coding actually. Uh, yeah,
so
it
actually I
was a
have an entry
website.
point.
So, which is
If you like, there's already collections of resources. Like, so if you search for awesome cryptocurrency hacking or awesome cryptocurrency security or something like that, there's collections already of challenges of security challenges about cryptocurrencies
oh yeah,
that have a
there's
lot of good
capture the
stuff in them.
ether.
And Yeah, the Fluidity. There's Ethernaut. Also, a viewer mentioned this in a comment. So yeah, Ethernaut is one of the most famous set of challenges. There's also Open Zeppelin has done one. Paradigm CTF is a CTF that has had 2 editions. Um, that's also pretty good, I believe. At least I hope it is. I wrote a challenge for the last part, the Paradigm CTF. So yeah, I think that one of the best ways to get started specifically with blockchain security is doing CTF challenges. I mean, at least I find one of the best ways, because like for the same reason, for much of the same reasons that doing CTFs is one of the best ways, I believe, to get into security, is that it gives you something to do, something like real to do, to actually get skilled, because there's a task, you need to solve it, you know that there is a solution to that task because it's a challenge. So it gives you
Yeah,
motivation.
true. Yeah, yeah. So you know that there's something that you need to find, you're supposed to find, I guess.
Yeah.
Yes,
It doesn't really. I mean, there's a ton of other stuff that you don't learn while doing CTF challenges, like all the human part, the development. I mean, how to organize the development workflow part. Meaning, I mean, learning to develop a smart contract is something that's not you don't really do that much while doing CTF challenges, because like usually you hack something
but do
together,
you
and
need it?
as long as it works, I mean, for the work you kind of need it, because since most companies that want to get audits are new, and they're small companies, very often they don't have the best development practices. Let's say
Okay, but
that way.
like, okay,
So
I see from a job perspective, but like just to be able to understand what's going on when you're starting by yourself, blah blah.
no, then no. I mean, you don't really need to know anything about the development tools to actually understand where. I mean, most of the time, at least, to understand uh, if there is a bug. There can be bugs, for instance, like in a contract being uninitialized, sort of has something to do with the deployment scripts, for instance. So you would need to know that part. But I mean, it's mostly relevant, I would say.
Okay, because I don't know, I found that some stuff at the beginning was confusing. When doing the challenges, the challenges, they basically tell you if you did the exploit right, and so you actually need to at least do some stupid stuff like invoke whatever contract they deployed on the whatever testnet they are using. And how
Yeah, well,
contracts are deployed, which is something that I found weird for some reason. Or the Ethereum, I don't know about Solidity.
yeah, well, I
But
mean,
so,
you need to be able to exit that to actually call. Usually, the way they're implemented, it's I mean, CTF challenges. The CTF framework usually gives you either like an Ethereum RPC endpoint that's private to you, and you can deploy your contracts there and use them to call. You basically have your own private Ethereum fork. And yeah, you need to have the basic knowledge of how to deploy a smart contract and call it. But that's usually, I mean, that's not a high bar. There's a ton of tutorials. So yeah,
yeah, yeah, sure.
it can be confusing. Like because also, I mean, you were mentioning JavaScript. There's the other overlap that there is with JavaScript. There's I mean, JavaScript is used especially for tests, and there's some sort of overlap. Also, for instance, npm is used to manage dependencies for the
What?
part
So
that
like,
runs on. I
so you
mean,
can install
most
like dependencies?
development tools are often written in JavaScript, and there's usage of the same tools. Like for instance, npm. There's usage of npm for
Okay.
managing stuff,
Weird.
but that's you don't really need to know that. That's usually you need to copy paste a couple of comments from tutorials to I mean, just like you don't really need to know how pip works to work with Python, or how uh, whatever package manager works or cargo works, for instance, to know to work with Rust.
Okay, so you're saying that in order to start, well, CTF style, like we did for the other security things, I guess, then probably you need to find out how to interact with contracts and stuff, get on the test network so you don't pay with real money for your test, I guess. And yeah, so did you ever have to like look into the implementation details of Solidity at some point? Because that's something that I need to start with.
Sometimes you might need, like, if you have some bugs, you might need to look into that. Most, I would say, no. Like there are some bugs which I tend to classify bugs in two categories, basically. One category is what I call a technical bug, that usually can be pinpointed to one single point in the code where there is a misuse of some specific technical thing. So you basically, maybe, I don't know, you've written a snippet of Vue assembly into your program. That Vue assembly is wrong, and to figure out whether you were able to exploit, or whether there's a problem or not first, and then what you can do with the problem when you exploit it. Then maybe, yes, you need to look into how Solidity works, or into how even the Ethereum virtual machine works. That's sort of rare. There's some internals of Solidity that you do need to work to know to be able to work in security on Ethereum smart contracts, but most inner workings, at least as a beginner, you don't really need to know. Of course, at some point you will want to learn them to find advanced vulnerabilities. And then there's
Yeah, sorry.
and and then there's the logic vulnerabilities, which are often the most devastating, and the most frequent, I would say. Like, that's the thing that I find interesting about all the things smart contracts, like as opposed to like a web application, for instance, where most of the logic is trivial. So it's like, I'll take a username, concatenate to a string, escape it. Ideally, that's not done manually, but like, you get the idea. Most of the logic usually is poor in web applications, and you need to find the technical bugs. Smart contracts is often the opposite. You actually need to figure out, like, most of the time, very often, is you spend understanding what the contract business logic is, and figuring out if it is implemented correctly or not, and if you can exploit it without involving any sort of buffer overflows, without involving any sort of like integer overflows, anything that's strictly technical, I would say. And that's an interesting aspect, and that keeps the job fresh, because you you don't get bored if you are given a different program every week, every couple of weeks, every 3 weeks, depending how long your audits are. So that's one thing that I find interesting.
Okay, so you're saying that there is like, would you say that it happens often that you find more like, because it seems that, for example, like the Solidity compiler and stuff, over time it started trying to save people from themselves, which I guess it's, as it happened, I don't know, on the desktop with ASAN, MSAN, and whatnot. You need to start getting into more complicated or logical, let's say, bugs, or like. What I'm asking is, do you have a ratio of stupid bugs versus logical?
So I don't have our data. I just don't.
No, like,
I should keep that statistic, but
estimation.
my feeling is 50-50. My feeling is 50-50. So 50%
Okay.
of the bugs are what I would consider technical bugs, which doesn't mean like super late, incredible bugs, but just things you did wrong on a purely technical perspective. Um, and the other 50%, again, that's just a feeling, but are like you implement you either your logic was designed in a wrong way, like from the start. So if you have a design document, the design document already has a problem, so you would have found that even without looking at the code but just looking at the documentation, or you implemented the logic incorrectly. But that's regardless of the language in which you implement stuff, you can do the same flaw, you can have the same logic flaw. So
But
that's why I tend to think in two categories of bugs.
how much, if at all, do you need to actually look at the standard? So okay, you have the Web3 part with crypto and blockchain and whatnot, but then it probably for most stuff, I guess they interact with external services or normal web applications. Uh, do you need yeah, no, yeah, do you need to look into that usually to find bugs and stuff, or you're just like look at the contract and the bug is there, or is it more like high level and you need to look at the interaction with everything else?
I mean, no. The smart contract itself is supposed to be safe on its own. So to find bugs in the smart contract is something that is generally isolated from the front end.
Okay.
That said, it doesn't mean that there can't be problematic interactions between the two, especially like there's caveats to this. So first of all, like basically the front end can have bugs, but I wouldn't consider it a problem of the smart contract. But maybe if the smart contract, for instance, registers some information given by the user, and then the front end reads it from the smart contract, and there's an XSS, for instance, there's an issue. But it's an issue about the front end. That said, the front end can have issues. There has been cases where the front end has been compromised, and user funds, or users were hacked that way by a compromised front end. There can also be cases where external programs, be it front ends running in browsers, or be it, other programs running on a backend or something like that, have vulnerabilities, and that's an issue if those elements are trusted. So there are cases like most designs. I mean, ideally, we are talking about DeFi, so decentralized stuff. Everything that's trusted is supposed to run on the blockchain. Ideally, that's not always possible or desirable, depending on what's being developed, and who's developing it. So sometimes there are elements of the system that are not on the blockchain and that are trusted. And if these programs have vulnerabilities, that can be bad. I mean, to give you a concrete example, there may be a program that pushes prices to a smart contract to give it pricing information, so an oracle.
I see.
And if you pawn the oracle, maybe you can manipulate prices. That's obviously bad. So yeah, we do. So from time to time we do. I mean, I have looked at off-chain programs as well. For me specifically, I most often look at smart contracts.
Yeah, it sounds like
yeah,
at that point you get back into normal web security, or
yeah, actually, that's one part where there's not enough attention right now about the front ends. Most of I mean, that's my impression of it. I have no data to say this, but my impression is that most of the financial resources that are being invested in the cryptocurrency space around security are for the security of the smart contracts themselves, which on one hand makes sense, because those are the things that are, I won't say mutable, because most of the stuff that nowadays is being deployed as in a way that can be upgraded and stuff, and so it's not strictly mutable, but it's something that where if somebody finds a vulnerability in a smart contract holding a lot of value, and they empty the smart contract, there's no turning back. Unless you're talking about the DAO hack of Ethereum some years ago, but that was a one-off, hopefully.
There is an interesting question that I should have gotten to earlier by Blue Minimal, which is lavish. This is true also for me, actually. I'm a crypto noob. I only know stuff like reentrancy. Could you like give out a, well, I don't know a list, but like, are there that many classes of bugs, and which kind of problems do people usually run into?
Well, how to answer this? Like, so yeah, there are recurring bugs. There are recurring kind of bugs. I won't make you a list because I would surely be forgetting half of them. I think there's also some projects that are kind of like OWASP, trying to classify the
Oh,
kind of
that's
recurring
nice.
bugs that you can see. That said, I mean, I'm not a big fan of lists like OWASP because they often leave. I mean, they often are outdated. They leave out interesting bugs. I mean, they're useful, but just up to a certain point.
So I
But yeah,
wanted,
there are recurring bugs. And one way that I mean, one useful way to see what kind of bugs there can be is looking at CTF challenges.
okay,
Again,
so you can keep up to date by doing CTS challenges?
uh, I would. Okay, there are not that many cryptocurrency related CTFs. So while for traditional security, you could say that CTFs are the leading edge in most areas, like not in, for instance, not in mobile devices exploitation, they're not. But for web stuff, I feel like CTFs are on the edge of what's like the newest trick, the newest thing, along with academic papers and some in some areas of the industry maybe. Um, and maybe for binary exploitation as well. I'm not that sure about this, but in cryptocurrency, I'm not sure. But for sure, you can learn a ton of techniques and a ton of bugs um,
Okay,
that
so
are relevant.
let's do something practical. If I give you the DAO hack, the DAO source code, which is really stupid
Yeah.
apparently, can you walk us through the bug and why it's a bug, and
Maybe
and maybe
I'm not sure. I'm not
let's
sure.
try
I
it.
mean, maybe I
Whatever.
know. If I'm not mistaken, it was a reentrancy bug, but I'm not
Yeah,
sure
yeah,
if
it
I can
was.
like spot it right now, right away.
But I wanna ask you a bunch of stuff.
And
So can you
oh
see
yeah,
the
by the way,
screen?
another thing.
No, you cannot.
No.
Yeah, yeah. Go on. Sorry.
By the way, another way you could find, no, common bugs or interesting bugs, stay up to date to the most interesting bug classes is looking at the hacks that are happening right now. So you go to some website like Rec News,
Yeah, I'm gonna.
and you read about the latest hack. It's a lot of fun. That's one of the other reasons. I mean, it's sad to say. Okay, so this
So you're saying that the best way to learn is to see people getting tons of money stolen from them.
yeah, that's why I was saying like it's sad on one hand, and it's a failure of the industry that those kind of tens of million like hacks involving tens of millions of dollars, even hundreds of millions of dollars, keep happening. And the worst part is that they keep happening even more than once. So like the fact that very big hack happens is already bad enough. The worst thing is that it happens more than once, because there is no process like in the aviation industry where when a big hack happens, there's a whole process around it to make sure that it doesn't happen again. There's no such thing in cryptocurrency. I mean, of course, a lot of people start to pay attention to a kind of bugs when it happens, but there's no generic process. So it happens that, I mean, it has happened and it keeps happening that the same bug is exploited more than once in different systems.
Okay, so can we try this experiment? If it doesn't work, it's my fault anyway. Um, can you read this? Is it big
I
enough?
can, yes.
I don't know if the people can because they have a lower resolution, but hopefully they can. So you're given this smart contract, you don't know anything. So how do you approach it? I guess. Actually, first question: how does the memory works in this stuff?
You mean memory? Okay, so Solidity basically has, or Ethereum VM basically has, there's temporary memory, you could say, and there's the contract storage. So the contract storage is the permanent memory that you have on a smart contract. A contract can store data permanently. So on the next invocation, it has the same data again.
But wait, so how does sorry, so let's remove this for a while. Yes, but so how does it work given that the contract is non-modifiable, is read-only, I guess?
The code is read-only, yes. What you can, but the contract has, it executes opcodes. There's a VM, and so there's opcodes for reading and writing to storage. And storage is the permanent area where you can store.
Yeah, okay. And it works like an hash map, from what I understood?
Basically, I mean, it's basically a hash map where there's like a key is any 256-bit value, and you can store a value to that key. It's a hash map in the sense that you can't list all the values that you've stored, so you need to know where you store them, and this is a problem for hash maps themselves. For instance, you cannot iterate, like Solidity has hash maps, but you cannot iterate on the members of on the stored values, on the keys of the hash map. There's no native way to do it. The way to do it usually is you keep an array of keys that you've stored alongside the hash map itself, so you can iterate on the keys. There's no other way.
So that's
and then there's storage? Like temporary memory, and then there's temporary memory. So like you have RAM basically, and then there's actually a third area of memory that's called basically where the call data is stored. So when you
is the call data? What is? Yeah, okay,
yeah. When you invoke a smart contract, you can pass data to it. And the data that you pass to a smart contract is stored in a special region of memory that is read-only, and that's qualified by call data. Like there's a call data qualifier in Solidity that you can apply to function arguments, and function arguments are stored in this special region of memory, which is read-only. And while we're there, like I was saying earlier, that there's a few language aspects that you probably need to know to get into security, even at a beginner level or sort of beginner level. One of those is the Solidity ABI. So when you call a smart contract, as I was saying, you can supply some data to it. You actually basically need to supply some data to it if it's written in Solidity, because the way it works is that every smart contract has a single entry point. And to decide which function you want to invoke, there's what's called a selector. So the first 4 bytes in the Solidity ABI, at least, and if you use another language or if you write directly in assembly, you can do whatever you want, of course. But like in Solidity, the first 4 bytes of that you pass to the contract are determine which function you want to call. And so there's a dispatcher switch at the beginning of every Solidity program that's automatically generated by the compiler that dispatches the call to the right function. And then the rest of the data is the arguments that are given to the function, which are encoded according to Solidity ABI, which is a whole thing.
So is it like in Ethereum, which for listeners, which is like Ethereum is the only thing I know, so that's why I'm asking. They take the method name and they hash it, and they take the first 4 bytes, I think?
Yes. The name of the function and the type of the arguments. So it's actually function name, open parentheses, the argument types separated by comma, close parentheses. You hash it with keka 256, and that's you take the 4 bytes of that, and this is the selector.
And so that's one of the things that was really confusing to me, because not many people, at least at the time I looked into it, lay out in details how it works under the hood. So there is a dispatcher somewhere at the beginning, a prologue before your method, but you're actually not really seeing it unless you do something stupid like I did, which is one of the first thing you do. You actually look at the disassembly of your contract.
Yeah,
and
you,
you can clearly
never
see
got
like
to that level.
the bunch of you never did because
As a developer, like as a developer, you I don't think there's
as a
any
developer you
reason
don't need it, I think.
to work with the dispatcher. With selectors, like the concept of selectors, you do need to know even as a developer, because sometimes you need to, for instance, to compose the call data to a smart contract manually. I mean, ideally you shouldn't
Okay.
have to, and there's often a better way to do it than
So
packing the call data manually.
okay, so there is like metadata and stuff that tells you the argument and blah blah blah.
I mean, I don't know about metadata, but basically, let's say you need to call, you take an address and you want to call some sort of function on that address. There's multiple ways you can go about it. Basically, you can treat the address as, you can do a low level operation saying, just call this address with this call data. And then you can like build the call data manually, however you wish. But if you know what the interface to that address looks like, you can say to Solidity, treat this address as something that implements this interface, and then Solidity will do the packing for you. So there's very often no reason to pack data manually. But if you're implementing an exploit or something like that, maybe you do need to specify call data manually. So.
But okay, so there is an API that it's standard.
Yeah.
Pretty much. Okay. Do you want to go back to the thing? Let's see. Okay, so this is what Solidity looks like. This is version 0, 8, 10, whatever. And this is actually, I think, the code of the DAOAC. So first thing is, what is mapping address to uint? Like, is that, so I guess that's permanent storage, I guess?
Oh yeah, that's basically a hash map in storage, and it's storing user balances. So it's mapping the address of some public key basically to a uint256 representing the balance that's held in the DAO.
Can you interact with the stuff if you're another contract?
Interact defined as in reading that
variable?
variable?
I guess not writing, because that would be stupid.
Well, no, writing, of course, not. Otherwise, like I would be able to change the balances of another smart contract. But yeah, reading you can. That's for every, and especially for every variable that is public. There's automatically, like Solidity automatically generates a setter, a getter for it. So there's actually on this contract, there's also a balances function taking an address. An address is basically 20 bytes of arbitrary 20 bytes that fetches for you the uint256 balance for associated to that address.
Okay, so when you, by the way, we didn't touch this, but when you call a contract or a method of a contract, basically you just need the address and, well, the method if you're doing some Solidity stuff.
You need the address and you need the ABI of the contract if you want. Yeah, and the money to pay for the gas fees. But if you want to call if you want to call a contract, you need to know the address where it's deployed, and you need to know what call data you want to provide it. And the call data you want to provide it, usually you encode it using the ABI, meaning you need to know what functions it has basically and what arguments it takes.
Okay, so let's look at the code back. So we have a deposit function which is public and payable. What does that mean?
Okay, public means that that function will be one of those included in the dispatcher that is executed at the very beginning of the program, meaning you can call it from the outside. Public functions and external functions can be called from the outside. The difference between public and external is that public functions can also be called by the smart contract itself, so it can self-call itself internally.
Okay.
Whereas external functions, at the language level, you cannot call external functions because those are marked external only. So you're not supposed to call them from inside your own contract. While we are there, I said that it's a bad language. Do you want an example why it's a bad language?
Yeah.
Do you want to guess what happens if you try to read a balance that doesn't exist?
Null pointer exception. I don't know.
No, that would be the reasonable thing to do, reverting, raising an exception of some sort. What happens is that you return 0. So if you try to read the balance for a user that does not exist
Okay,
in the
okay, so
in the
memory
map,
zero
you get
initialized.
0. But so essentially, so if you try to read a U into 56 and it's not initialized, you end up with 0. If it was a boolean, you end up with false, which, I mean, it's kind of reasonable because you do know what you get back. It's not random data, at least, but I argue it's really bad still, and it has caused bugs because you basically need to always think about what happens if you, like, while developing a smart contract, you also need to think what happens if you try to read something from a map that wasn't ever set for a key that doesn't exist.
Okay, so my memory model for this would be you have a hash, not really a hash map. Basically, all the memory is a huge memory that is addressable by a 256 bit value, and it maps into 0.
Yes.
Well, everything is 0 except the stuff that is, well, it's 0 initialized.
Yeah. The memory is 0 initialized.
And the way you achieve the hash map is doing the hash thing on the key that you're using to address that memory.
So the underlying memory is addressed by keys that are, I was saying, like 256 bit keys. And then if you want to implement a hash map on top of that, like the way storage is implemented in a smart contract is that you take all the variables, the storage variables of the contract, and starting from offset 0, like from key 0, you start storing the associated data. The way hash maps work is that, or arrays, for instance, is that you pick whatever offset you want into, I mean, the compiler does it for you, you don't do it manually, but the compiler picks whatever offset it wants inside the memory, so at random place in memory, for instance, let's say, and the values of the array are stored there. What you store at the root variable for the array is only this offset in memory, like the key where the array starts. So you have at the beginning of the smart contract storage, you have metadata essentially telling you where the actual data is in for complex data types. Of course, if you have like an integer, you can store that directly. You can store it there directly. That's how it works. And
do you know? Do you actually need to think about it apart from the 0 thing when you're doing reviews or stuff?
Sorry, come again?
No, like, I mean, this implementation, this is just like an implementation detail. Apart from it returning 0 when you're trying to access something that is not there, do you actually need to think about it if you're trying to find bugs?
Yeah. I mean, can be cases where, for instance, a developer assumes that it's a case of fail open design often, which is bad in and of itself. But like, there are cases of fail open design where they assume that for each user of the smart contract, they've set something in storage, and someone who's never been a user of the smart contract, so maybe that's a permission set or something like that, and 0 means you're allowed to access the contract. That's obviously bad, but like, there are cases like this because developers sometimes don't think about what happens if
the wrong data,
if there's if a map is uninitialized. It's not uncommon. And I mean, permissions is maybe not the best case. It's not it's not often that 0 means you're allowed to do something, but for prices, for instance, or timestamps or something that is associated with some other logical data type, that happens. Sometimes the programmers forget.
Yeah, that happens in C and C++ too. Whatever. Okay, so let's go back. What is payable?
Oh yeah, payable means that if you call deposit with an amount of Ethereum associated with the call does not revert, because by default functions are not payable. So there's a check also inserted by the Solidity compiler that if the value associated to the call like the Ethereum value associated with the call is non-zero unless the function is marked payable. It will there will be a revert, so the transaction will be
Okay,
undone basically.
so your payable means you can send money to the thing.
Yeah, you can send Ethereum.
What if I send money and the method doesn't do anything with it? Can it?
Then the balance is added to the smart contract balance. So every address in Ethereum has a balance of Ethereum. And so when you call a smart contract with some balance, that balance gets added to the smart contract like immediately. Then if the smart contract sends them away, that's like something on top of the.
Okay, so in this case, the balances would be a variable that I use, like me being the contract developer, to keep track of who's sending me the stuff that is anyway accounted
Yes,
in this
yes.
contract itself. Okay.
Yes.
Okay, then I guess
message
require... Yeah, sorry.
In this case, like message value contains the amount of ether that was sent along with the call. Balances is like some internal data for the smart contract. It has nothing to do with the actual Ethereum that was sent.
Yeah, it's just a number.
Like
yeah.
that is owned by the DAO contract. And the current balance for an address, you can get it by name of the variable containing the address, basically dot balance. Like there's a dot balance property that you can read.
Okay. And then we have, require is an assert. Sender, I guess, is the person and or contract sending the money.
Yeah, message sender is message. Technically, the definition of message sender is whoever has initiated the call to the contract, which is different. This is another vulnerability that was kind of common like years ago at this point, I guess, which was using oh my god, lapsus. Sorry. Another property, not of the message, but of a transaction, transaction origin. So there's two properties that you can read to figure out where a message comes from. One is message sender, which is the one you should use basically always. And there's also tx.origin, transaction origin. The difference is that tx.origin is whoever sent the transaction, but a transaction can have multiple calls, and you can also call a contract, and then that contract calls your contract that you're writing. Okay, so the difference is that tx.origin basically never changes. It's always the root value. You can.
Okay, so it's like the first thing to call.
Yeah, whoever has initiated, has initiated the whole chain of stuff that is going on.
Okay.
Whereas message sender is whoever has called you. So if there is user A calls contract B, calls contract C, C sees as tx.origin sees user A, but sees as message sender contract B. And there was a period where this wasn't really well known, and the issue was that if you relied on tx.origin to do authorization checks, there's issues with that if you trust other contracts that you could then cause to call that could be used to call you. So if you trusted contract B to not perform evil stuff, but someone could call into contract B to call contract C you're developing, that's an issue.
Okay, yeah, that's a fact.
It's kind of old. I think I've never seen such a vulnerability. It's like very old stuff.
I remember. This is like I did this more than 1 year ago, so I don't remember much. I remember there was some difference between when it's a contract sending the money or an account. I don't know, something like that. Can it be? If it doesn't make sense, it's probably me messing up.
I mean, there are.
There is some value that is zero when it's not a con. I don't remember. Jesus. Well, anyway.
Yeah, you can distinguish if you're being called by an Ethereum only address or if you are so not a smart contract, or by a smart contract. Basically, by taking the address of the whoever is calling you, so message sender, and checking. There's an opcode called Xcode size, which allows you to check if the code associated to a given address is like the size of the code associated to that address. That is non-zero if you are being called by a smart contract. However, there is a caveat to that, and that is that if you are being called by a smart contract that is being constructed, the external code size, since it's not actually already deployed, the Xcode size for that is also zero. So doing the check this way is not bulletproof.
Okay, so you're saying that during the initialization of a contract, the contract looks like a Ethereum only.
Sort of,
address?
yeah, sort of, yeah. If you collect code size on the address of a contract that is being constructed that has called you while it was in its constructor, basically, since the contract has not been deployed yet, there's no code associated to that address.
Okay.
So,
okay. Yeah. Okay.
So this trick doesn't work.
So another, this is before going back to the code. Can you speak about how the contract, like the contract deployment on Ethereum works on two steps? In two steps.
Yeah, I mean,
can you speak about that, because that was super confusing to me.
Basically, the way it works is you send some code to the blockchain. It gets executed, and one of the possible opcodes that exist is create 2. Okay, there is actually 2 opcodes for deploying a smart contract. One is called create, and then they saw it sucked because it was hard to predict in which address the contract would end up, because it had okay, so the address of the smart contract is basically a hash of various stuff. Okay, the original create opcode included in the stuff that got hashed the block number or something like that. So it was hard to predict on the address of the deployed contract. So they added a new opcode called create2, which makes it easier to predict where the address of the deployed contract. So yeah, the way it works is basically you send some opcodes on the blockchain, which build whatever the bytecode that you want to deploy, and then execute the create2 opcode, which deploys a smart contract and basically assigns the code to the smart contract address. This is used by Solidity. Like if you use not constant, sorry, I don't remember the keyword for it. Wow. Anyway, there's a keyword for saying this data can only be set by the constructor and then never changed again. The way that's implemented is that that variable
is final.
No, it's not final. It's
static.
Whatever.
Let me guess.
Not even. But anyway, yeah. Anyway,
go on. I will search for it.
The way that is implemented is that it changes the bytecode itself. So it embeds whatever constant you want to set that variables to in the bytecode, like in line.
It's constant here.
Maybe it is constant then. Okay, maybe it is constant. Okay then.
Okay, so when the constructor is called, it sets this thing, and then it becomes part of the actual deployed contract. So that's why you cannot change it. Yeah. Okay.
Yeah.
So if you have a bunch of constants, it means that your contract is getting bigger. Yeah. Well, makes sense.
Yes, but it still costs less than, or the same or less than using storage. So
no, we don't care about that. It's fine.
And
yeah.
There was another thing that came up to my mind. I forgot. So.
Okay, so now we know how Solidity works, and we have another function, method, whatever, which is withdraw. It's public. It does a bunch of checks. If you want to go on, it's super stupid actually. That's why I like this example.
So do you want me to go on and read the contract and
No, yeah.
explain
Okay.
what's wrong with it?
So we have like here we have a withdraw function that is not payable, so it means that it cannot receive money. That's what I understood.
Yep. Yep. You
It
cannot
checks.
call it directly and send it Ethereum.
Okay. So here it checks if the balance is equal or greater than 1.
Yes,
So we know
one
that
ether actually. So ether
one ether.
is a constant. So it's secretly multiplying one by 10 to the power
Whatever.
of something.
Then it gets the sender, which is the guy calling this contract, not the guy starting the transaction, as we just said. Gets the balance, which is a very big number apparently, and then it does message.sender.call with the value. So I guess that means like sending the money to the sender.
Yeah, because basically the way
Yeah.
Ethereum is transferred is that you call if it doesn't matter if it is an address or a smart contract. Like for what the VM is concerned, it's always a call with some value of ether attached to it. The empty the empty string is the call data. So the call data is just an empty string. So there's no call data to this call. You just end up calling the address of message sender. So basically, you're sending back the value of message sender.
What's wrong with it?
With this call specifically, well, by itself,
with this
function. Okay,
with this function.
The issue with this function is a reentrancy issue. So a very basic one at that. So basically, the way it works is like follow me for a second. So let's say I call withdraw. I have enough ether in as my balance. So the contract reads my balance from storage and then calls my smart contract again. It calls me again. So let's assume I call this not from my Ethereum address, but from a smart contract which has code. So the way it works is that when, like, if I call this from a smart contract, the smart contract will be called back with the Ethereum value that was its own balance in the DAO, right? So what I can do is that since I'm called, I have the opportunity to execute code again, and the code can then call withdraw again.
So wait. So if I'm not I wouldn't be able to call this if I'm not a contract, I guess.
If you are a user, you can call it like if you can call a smart contract directly as a user. But then if the smart contract like performs a call on an address that doesn't have any code, it just ends up transferring whatever value there was.
So it's just a transfer
there's no
of
code,
money.
so no code. Yeah, exactly. It's the transfer of Ethereum, but there's no further code being that will be executed because there's no code associated to that address. But if a smart contract calls another smart contract, then of course the code for the smart contract being called will be executed. So if I initiate the call to the DAO from a smart contract, then the withdrawal happens up until the message sender.call line, so line 22, and we end up back again in the smart contract that has called the DAO, and that smart contract can again call withdraw. And what happens now is that it checks if the balances in the associated to the message sender is still greater than one ether, and it is, because the last line, the setting the balance to 0, is only after the call is completed. So when we re-enter into the contract, the balance is still not updated and is still the old value. So basically, I can ask, I want to withdraw all my ether associated to my balance. It will send them to me, and I will ask again and again and again and again and again and again in a loop, emptying the balance of the smart contract. I just need to be careful not to, or to catch the revert, because at some point, if I keep doing this...
what happens if I finish the money to run the thing?
It will cause a revert, because I'm trying to call a smart contract with more value that I own. So it will cause a revert. But there's there is a concept of a try catch. So you can basically catch that error and stop and unwind the whole stack of calls start. The other thing, you're probably more likely to incur in an out of gas situation. So like there's a gas
And that
limit
is different from a revert?
it also causes a revert.
Okay.
Basically, the point is that there's a maximum execution, like there's a limit to the execution resources that you can ask the transaction to process, and you need to fit into that. Like you can set your own limit. You just need to be careful enough to have a high enough limit that you don't cause a revert by just running out of CPU time, quote unquote.
Okay, so yeah, so that's like a pretty much an infinite loop without updating. Well, not infinite, but let's say infinite, without updating the balance. And
Yeah.
let's see, this is the exploit I found. So we get external here, so they are defining, I guess, the interface to call without having to encode the data, as you said earlier, which is good.
Yep.
We got our constructor here that is gonna set this during the constructor, blah blah blah, and this is the stuff that is gonna get hard coded, correct?
It's the vulnerable DAO contract to be exploited.
Yeah, but I mean after the construction, that would be a variable. No, this is not constant, I guess.
It's not constant, so it will. It's not optimal. This will be
Okay.
like the DAO address will be stored in storage.
Jesus. And so we got the attack here, which deposit message of value, which I guess is 1 ether to bypass the check at the beginning of the withdrawal function.
Yeah, because you needed to have some balance in the DAO to be able to withdraw them.
Okay, what is fallback?
Oh yeah, so I was saying that there is a dispatcher, automatically inserted by Solidity, by Solidity compiler. The fallback is basically the default case in that switch. So if you have defined the fallback function, the fallback function is whatever ends up being called if no other function matches the call that is being done to you. So you need a fallback function because
it's like the
default in the dispatcher switch. The reason why you're defining it as a fallback function is that the contract was only performing a low level call without any call data. So there's no discriminator. There's no selector. The 4 bytes that we were saying earlier, encoding, like basically hashing the name of the function and the parameters. So to write this in Solidity, you define just a fallback function, and you end up in there when you're re-entering the contract.
Okay, and so this goes back to withdraw, and since this line here is here, you still have more than 1 ether, and so you're looping. Well, you're doing recursion actually, but looping, let's say, and getting the money. So that was pretty interesting. The first time I saw it, I was like, what the fuck? This fallback stuff is like the fact that if you send money to an address, you could get hacked because it's a contract that is running some custom code. Really, it's not a concept you're used to when you're doing normal programming, I think. I mean, I wasn't, at least. I don't know. That was kind of surprising. Like this is one of those things that I wouldn't expect to happen. That's what I'm saying.
Yeah, no, you need to there is some mindset that you need to get used to. Like this specifically, like the fact that there can be some value associated to smart contract transactions is one thing. Then there's a whole other paradigm or set of possible interactions that you need to get used to when you're working with tokens, because in Ethereum there is like the Ethereum currency, and that is privileged. It has special status in that it has native support like at the VM level, so calls can have some value associated with them because like it's Ethereum, it's the native currency. Then there are tokens, and the way tokens work is that the balance is actually what is stored in the storage for the smart contract managing that token. And there are instructions, like there are functions that you call to perform operations on the balances. So there's the by far the most popular standard for implementing tokens is called ERC20. And it's basically an interface. Like, think of Java interfaces, like an interface that you have to conform to be to follow that standard. So there's functions like transfer or transfer from that you can call to transfer values, like to transfer a given amount of token to someone else, or to transfer an amount of token from someone else. And to transfer it from someone else, you first need approval. So that someone else needs to first approve you to manage an amount of funds from them, and then you can call transfer from and transfer those funds on their behalf. And this is a mechanism that is really, like, you would think that it is not really that common to give approval to someone else or to some other contract to manage your funds. That's actually not the case. It's really common because due to the way that Ethereum works, and due to the way that transfer from is the only option for, when you want to basically use a smart contract to manage your funds. The way you usually do it is you give it approval for the funds that you want it to be able to manage, and then it performs the transfers on your behalf. This is done because there's basically two ways you can do it. Either you first transfer the tokens yourself to that smart contract, and somehow that smart contract keeps track of who sent him what.
Okay.
But that's kind of hard.
Which is, I guess, what the contract we just saw was doing. No? Yes?
Yeah, but not really, because the DAO was using like Ethereum, so the native currency.
Oh yeah, okay.
I'm talking about like tokens, and like the difference is that tokens always need to be transferred by invoking functions.
Okay.
And so there is basically like a standard authorization mechanism, a standard operating framework for tokens, where basically you can give some contract or some address authorization to spend on your behalf your balance or part of your balance, and then that someone or that contract, that address can spend it on your behalf. It works like this because you can first give approval, and that in and of itself is a harmless operation in that it doesn't transfer money, but it gives them approval to do so. And then you call whatever contract you want, and that contract is authorized to use that money, that token.
Jesus. Yeah, I don't think I got
it's really not that complicated, but like I just explaining it
I need to read it on paper and see some diagrams and stuff.
You need to do CTFs on this, trust me.
Yeah. Well, it will happen, I guess. Crypto CTFs are becoming more popular, I think, if this crypto thing continues and our sponsor keeps up. And some interesting news recently. Anyway, so yeah, we saw a pretty basic smart contract, and also the token thing, which is not too complicated, but it's a bit complicated. Random questions. Do you think are binary only contracts popular or used at all?
By binary only, you mean contracts for which the source code is not available?
Yes. Like, do apart from, I guess, if you do an audit, you're gonna get the source code. But I don't know. Maybe CTS, but I don't care maybe too much. But are there projects that you know of that are using that actually only deployed the bytecode without giving the corresponding source code?
Usually it is a red flag. So
I
at
guess
least
so.
in Ethereum, in Ethereum, it is really, 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 really common to give out the source code, so to open source the smart contract part at least. Like the front end, maybe not. The whatever is not on chain is maybe private, but the smart contract itself, if it's not open source, it's usually not a good sign. Because like there's basically no good reason to keep it private, like none at all. However,
I'm
like it
asking
depends on the
this.
platform.
Yes.
Like in Ethereum, it is really rare. Like there for sure there are some which are not open source, but I cannot name you like any.
Okay.
There's other platforms where keeping stuff closed source is more common. Like for instance, in Solana, for instance, it's just because it's one of the other few platforms where I kind of know best. It is not that uncommon to have closed source programs, and it is a big issue, in my opinion, because also because like Solana is much more complicated. Like you have a Rust program that is compiled to eBPF, and you can get like a whole elf out of the blockchain, and they can now being like megabyte sized programs. So good luck figuring that out. Like you can reverse engineering an Ethereum smart contract is probably easier, I would say.
Yeah, I guess so. I'm asking this because on in the Vinya talk, and well, also like I started trying to do a fuzzer, and the way I did it was I hammered a fuzzer inside the actual VM, like the Golang, the official VM implementation,
Yeah.
and it could work, and that's how I figured out there was the selector at the beginning, because my fuzzer was finding the magics to call the methods, and that's how it got coverage. But also, like with Vina talk, he talked about lifters and stuff like that. So I wonder, is it because it's easier to do symbolic execution on the bytecode, I guess, than so you need a lifter? Or I was wondering, like,
Um,
yeah, do they actually need it because they don't have the source code and they cannot like do some LLVM style uh, intermediate whatever to write their analysis upon.
I mean, both
If you don't know, it's
approaches
fine. It's
can
just a question.
work. No, I mean, I don't know for sure. I can only give you my feeling about it because I don't, I can't say I worked on like on symbolic execution or static analyzers for any extended amount of time, like apart from a passion project level of knowledge. So I can say I'm an authority on it. My feeling is that both approaches can work, and they have, of course, they have like pros and cons. Of course, if you start from the source, you have more information, you have more high level information on the contract, so you can do more advanced reasoning easily or easier, I would say. And whereas if you start from the bytecode, your approach is universal, and you're agnostic of the, I mean, at least in principle, you can be agnostic of whatever language was used. For instance, like Solidity is not the only one. For instance, there's this other languages as well. They're all virtually unused, to be honest. But there's Viper. There's other languages. Viper is like if you don't want Solidity because you don't like JavaScript and you want the Python feeling instead, you can use Viper, which is basically Python, if you really want it. Um, I don't
Uh,
know what else.
let's see what Lavish has to say.
Oh, this is a good question. Yes, there is a way to verify the build. The way to verify the build for at least for Ethereum for Ethereum Solidity smart contracts is that you take the very same compiler version that was used for compiling the contract, which should be there's a pragma directive that you can set to specify the compiler version. It can be like a minimum limit, or it can be a specific version. Of course, specifying like a specific version, it would be better for this purpose. But yeah, you take the very same version, and you try to compile the smart contract. There's at least one more detail. that you need to add to have reproducible builds, which is the optimization parameters. Basically, there's one parameter telling the compiler how many runs it needs to optimize the compiler for. Basically, it uses this information to pick the choices, like the trade-offs between code size and I'm sorry, the optimizations. I mean, to take decisions based on the assumption of how many times the smart contract will be called, with respect to the amount of gas that you need to, for instance, to deploy the smart contract, or stuff like that. Basically, it informs trade-offs, optimization trade-offs.
Makes sense. Like if it's a
So
contract.
the short answer is yes. There is a way to verify builds, and if you go to Etherscan, for instance, and you pick a random smart contract, there's a tab for the source code. Most smart contracts, like smart contracts, you can start to trust. Submit the source code to Etherscan, and Etherscan does this verification for you. Like, it verifies that the smart contract, when compiled, matches, like the bytecode matches. You shouldn't really trust it entirely, in the sense that there has been an exploit in like a vulnerability in Etherscan, where they were using Unicode fuckery to hide parts of the smart contract. If I'm not mistaken, there was something like that going on. So
that happened. There's a paper about that for C, I guess. There was a paper at Usenix or something. Exactly that, like using Unicode to hide source code in the source code.
I don't remember the details, but there was some problem with what you could see versus what actually got compiled.
Jesus, that's interesting.
I don't know if it was exploited in the wild, or in the wild, or if someone found it and had a laugh, and that was it. I am not sure.
They should have kept it ASCII only. Unicode was an error, telling you. I'm sorry, international people that needs weird characters. Anyway, we are at, let's keep it in under like 2 hours. So let's try to do something quick. If anyone has any questions, shoot. Otherwise, my question is, do you use any tool that is like something more than VS Code or something? Like, do you have any tool that helps you in however way?
Yeah, well, me personally, I tend to use. No, me personally, I tend to. Well, first of all, like JetBrains IDEs, especially for Rust stuff, are like. There's no, in my opinion, there's no.
Okay, so that's for Solidity.
Honestly,
sorry, for Solana.
for us and stuff like that. Yeah. And for what concerns Solidity, like IDE tools, there's, like, for aiding security audits, there's a plugin for VS Code that is, it's helpful. It highlights all external calls. It gives you call graphs. It's called one sec. Let me check out what was.
But is this just like the normal the normal language support for Solidity, or is it just like
no? It's another extension, like, it's specific for security. Okay. It's called Solidity Visual Developer. Okay, but it has a lot of like stuff that is helpful for security. That said, I mean, it's not fundamental. Like, just helps out, like highlighting, for instance, inputs that are arguments, like variables that come from arguments or external calls. So you have a warning sign around or near calls to external contracts. And then other tools, like there's a couple of tools that I do use like routinely during audits. For instance, there's Echidna is a fuzzer. I don't use it that much, to be honest. And
how
then there's Echidna, like the animal. But if you look for basically
I'm looking. It's okay.
And there's Slither is another one. Like, Echidna is a fuzzer, and Slither is a static analysis tool. It catches some stuff that is actually useful. So I can recommend Slither for sure.
So you're saying that they're gonna steal your job, pretty much.
No, not anytime soon. They, as all static analysis, like it's limited. It sometimes it can help you catch stuff that is trivial or boring to catch, but like the logic bugs, there's no way you can catch them with static analysis. If anything, you can. There's another approach that you can take is formally verifying smart contracts. Um, but of course there's no like automated approach to it. You just need to put in a lot of work in defining what invariance the smart contract like must hold for the specific smart contract you're analyzing. So at the moment it is not an approach that is common, because the most productive thing to like the most productive investment of auditor time right now is probably still manual auditing, because the tooling for formal verification and stuff like that just sucks. It takes too much time to do anything useful.
Is there any like tool you wish you had, or that you see people are researching? Do you follow like academic research at all? I have a friend
I
at
don't
UCSB that is doing some interesting stuff, but
Not really. I'm not really informed about the state of the art in academia around cryptocurrencies. I believe that one like most, like
because
for instance, for
I
sure.
think they are fine. Like I don't know when it happens, how many months ago or years, but recently I've seen a bunch of academic people starting to research into that, because it's a cool area. It's a greenfield thing. You can do whatever you want, and it's gonna be a paper pretty much. That's my understanding. But yeah. So
Yeah, I
how do you
think
keep up? How do
there's
you
a
keep
lot of
up
research
with?
going on in zero knowledge stuff. I think both in academia and in the real world. That's very interesting. That's an area that is very interesting, but it's not
I don't know what this
um,
is.
what zero knowledge. Oh, the
No,
link
no,
that
no.
you just sent.
Sorry. Yeah, yeah. Whatever.
I don't know either. I will check it out.
Anchor. Yeah, yeah. We'll check later. It's a sound static analysis for Ethereum contract, and it was created by. Let me see. Okay, Matteo Maffei and other people. I thought it was about the guy who posted the comment. But anyway, Lavish, don't interrupt. Sorry. Zero whatever proof.
Yeah, zero knowledge proof is an area that is being actively researched, and actually, I think that cryptocurrency is like I'm not I'm no expert. It is actually hardcore crypto, not as in cryptocurrency, but cryptography stuff.
We don't care about
I think that
cryptography. We are only
no, I
interested in
do care,
crypto.
and I find it really fascinating. And like, I wish I was smart enough and I knew enough math to actually be able to understand it at a non entry level, at a deep level. But like recently, I was involved with an audit that involved a zero knowledge stuff, and I found some really interesting bugs. And I actually had the opportunity to study how some of that worked, and it was really interesting. And it was a sort of a simple application of zero knowledge stuff. So luckily, so I was able to understand it, putting in a lot of effort. But yeah, that's a really
And
interesting research
well,
area.
I have a bunch of random questions, but there's no time. Fuck! I really wish we jumped into the actual Solidity earlier in the stream, but whatever. We did the best we could. Where can people reach it? Reach you, sorry. Apart from
I still use Twitter.
you, don't you know about the Mastodon thing? Don't you want to write some mastodons, which I guess is the name of the tweets?
I th- well, I have a Mastodon account on InfoSec Exchange. So if you want to reach me there, I think I get an email if you message me there. I think, I'm not sure.
I really want to see where this Mastodon experiment is going to lead. Probably to people moving to Reddit or something. Okay, so Twitter is the place to contact you if they wanted. I don't know. If they want to also get a job, there are jobs out there. Don't spam him, but maybe spam him if you're good. I don't know.
Oh, if you want jobs, do spam me. I mean,
Okay.
we're always looking for new guys. So yeah.
Are you looking for juniors? That's, I guess, what's most interesting to people.
I think that if you, I mean, depending on the definition of junior, like if your definition of junior is I am not experienced in cryptocurrency hacking, but I already did a ton of CTFs, or I'm
Yeah,
already
that's what I'm
experienced
saying
in
as junior. Yeah,
doing
yeah.
security audits. I think that the time, like it can get bootstrapped very quickly.
Meaning
Because
a month,
there's a
2
lot of knowledge
months.
transfer. Meaning that that in that time frame, I think you can get actually productive in auditing smart contracts, and then you can learn as you go. At least speaking for where I work, we are audits. We are always paired in audits, and if there's a new guy, it tags along. So
Nice. That's
like
nice.
two experienced guys at least, and then if there's someone else learning, it tags along. So yeah, it is possible to get started quite quickly.
Okay, good to know. Final question that I have. No more questions from the audience. So my last question is, what crypto should I buy?
If this is
You
not
don't
investment
have.
advice, I don't.
You don't have to answer. Yeah, I think
Right now,
that's.
I would say probably none, considering the economic
Yeah, it's
climate.
going
But
down. It's going down.
I'll stop
Do you
there.
hold any NFT?
I
Because
don't know. As
I
I was
wanted
saying
to.
before, as I was saying, like I'm extremely risk averse as a person. I don't hold any crypto because like I already worked in there, so it would be kind of risky to hold crypto and also work in crypto. So if stuff goes to
But
shit,
there is. Wait, let me see if it loads. But there is an NFT you can buy if you want, and that's the mhackeroni NFT, which is actually somebody stole it on another blockchain, or one, like not on OpenSea, because we all know NFTs are very secure. Anyway, that was an attempt at a joke that didn't work. Thank you, everyone. We are just under 2 hours, which is really too long. I need to eat and go do some stuff. Thank you very much, fcremo. You can follow him, but you should also follow mhackeroni on Twitter, Instagram, LinkedIn, Facebook, Mastodon, TikTok. No, we are not there yet, but we're working on it. If the US doesn't ban them from from everywhere. And thank you very much. See you next time. We're gonna speak about how to keep in shape and touch grass.
bye guys.
Bye.